Welcome to qnawire.
So first thing we want to do is recognize what we're looking for. The net rate of outflow will be given by this formula right here. There's other formulas too that we might end up using though. So since the density is constant at 1025, and we know that V is yx0, that tells us that F, which is the density times the V vector, is going to be 1025 times yx0. That's a helpful piece of information that we'll be able to plug in later on into our formula. Then if we parametrize the surface, we see that R of U is going to be 3 sine V cosine U. And this is R of U, V 3 sine V sine U, and 3 cosine V. Then with this in mind, we can now take F of R of UV, and we know that this will be equal to the 1025 times this. The X portion will go right here, and then the Y will go right here. That's an important thing to know as well. We know that the same thing applies where this is also the same. So instead, what we'll do is find the unit normal vector. So we'll have to take the cross product of RU, the R derivative, partial derivative with respect to U, and cross that with the R partial derivative of V. When we do that, we note that the R derivative of U, partial derivative, will get -3 sine V sine U plus sine V cosine U. And then the partial derivative of R with respect to V will be 3 cosine V cosine U, 3 cosine V sine U, and -3 sine V. So when we take that cross product, what we end up getting is a -9 sine squared V cosine U, and this will be a vector, -9 sine squared V sine U, and -9 sine V cosine V. So that would be our vector that we end up getting by taking the cross product. So as a result of that, our ds is going to be this dA, but the negative version of this dA. So we'll get rid of all the negative values, and we'll put a dA. So as a result of that, we know that we're going to want to use this formula right here. Our F that we have in this case is going to be, we can pull out the 3 and make this a 3075. And then this sine V sine U, sine V cosine U, 0, is going to be multiplied by these values in here. So as a result, what we're going to end up getting is 3075 by taking out that 3. And then this will become all sine cubed V sine 2U. Okay. We know that U is from 0 to 2 pi and V is from 0 to 2 pi. So we'll put those bounds of integration on each one. And then we can also separate this right here. Instead of dA, we'll have du dv. So that'll be our dv portion. This will be our du portion. And then if we make this the sine of v cubed, you see that we end up getting 0. And the reason for that is because this right here evaluated is going to be 0. So no matter what, we'll end up getting 0. And that ultimately tells us that the net rate of outflow of the seawater will be 0.